Professor Donal Bradley and his team at Imperial College are using organic materials to construct the next generation of electronic devices. Their research combines the properties of plastics with the functionality of semiconductors to create innovative technologies at dramatically lower production costs.
What we're working on are materials that are very familiar in our world. We're working with plastics, and people know a lot about plastics as structural and insulating materials. The exciting thing here is to say that we can take a plastic and change its properties from those of a conventional plastic to be a material that will conduct electricity, that will behave as a semiconductor, that will emit light. The idea is that the solution processability of those materials means that essentially they behave like an ink. And we're familiar with inks from magazine, colour, printing and so on. The idea is that you can essentially use the same processes that you would use to make a nice picture in a magazine and to actually deposit an electronic device that way.
The team is using two familiar fabrication methods. One is a simple stamp transfer technique which deposits organic polymer films layer by layer. The second is photolithography. In each case, the team has developed a new approach that offers significant potential for manufacturing efficient electronic devices.
Historically, the problem with polymers has always been that once you've laid down one layer, putting down the second layer tends to damage what's underneath. But if you put down the polymer as a solid film, that doesn't happen. So you can begin to build up very complex structures and structures that got higher performance than the simple structures used previously. In that way you can get higher performance from organic devices.
This plastic electronics technology has many potential applications, including lighting, solar energy, imaging, medical diagnostics and communications.
If we think of the evolution in televisions, we're familiar with the recent evolution from cathode ray tube, big bulky display, to a flat panel display like a plasma display or a liquid crystal display. This technology offers the benefits of both, so it has the picture quality that's obtained with a CRT, but it combines that with a thin film flat panel format. There's also the possibility of making a display on a flexible substrate, so you could have a device that could be rolled up in principle. You could have displays on clothing, you could have displays on curtains, and any sort of surface essentially could be used to put a display on.
Then it heralds the potential of revolutionising device fabrication. It means that you can make very high speed, a very large number of devices, of very large size, in an affordable, high throughput format.
Certainly printing electronics has the potential of changing the world. Intuitively, if you think about the appeal of it, like using printing processes to generate large-scale electronics products, devices, photovoltaics, solar cells, lighting modules, that sounds very commercially appealing. It's low cost, addresses contemporary issues of burning importance like climate change, how to produce more environmentally friendly, energy-efficient technologies. So it could be really world-changing, could create a new industry. It's very exciting, a great opportunity, and we want to give it our best effort.
There are very few opportunities for taking proof of concept, very early stage technologies like these and actually accelerating them to the next stage. Well, the beauty of the Brian Mercer Awards is it really allows us to continue developing the science in parallel with the technology, and I think that's got to be its key strength.